Now we are going to deal with this part first. This part is, in many ways, is simpler. Why is it? Because this is about the direction of a unit vector. In other words, you see, if you have a unit vector, what matters is the direction itself. So now here is a thing that I explained in class, why we emphasize a lot why this unit vector makes pretty easy to do that. Suppose this is the direction that you are interested to do the calculate directions. So this is your unit vector direction. Now you see, I can translate this unit vector whichever that I want. You see, in the beginning, we choose origin over here. You remember that? And we can translate this unit vector all the way to this side. Remember, we are translate unit vector. So that's where unit vector is going to be. So in other words, you see, the thing that I mentioned here is that this unit vector can be translated any place that I want. Where you want to go? Well, the idea was that it allows to me to simply see where this theta or phi direction that it will be. Suppose this is your z-axis. Now, before I translate, I did not even see where the theta angle that is. But once I translate it, you see, now this theta prime comes out immediately. Okay, so now when I do this, so in other words, this direction only matters with the theta and a phi prime. So you see here, I have a theta angle. If I project this unit vector onto the xy plane, I am going to get phi prime, something like this. So this is your x-axis. Once you project onto the xy plane, you probably have a little vector like this. So then you can see this little angle here is your phi prime. You can figure this out. So in other words, unit vector only depend on two things. One is the theta, one is the phi. So that's why we deal with this first. And in other words, you can write them down like this shape. That's perfectly fine. That's not a problem. But when you do the calculation, you only have two choices. One is either use Cartesian coordinate, which means this one here, it becomes like x sub a along the x direction minus x prime. And then you have the same thing for your z component and the y component. It will be the same thing. And then when you do the integral, well, good luck. You can find this out if this integral is possible. But if you have a system that's spherical, you definitely need to convert this one to theta phi. Sometimes in the non-spherical system, we still use spherical ones because that allowed us to do the integral easily. So this is the direction you figured it out. In other words, whenever you have this situation and you figure out direction like this. Now I'm going to show you two examples. First example, which we did already in class, like this. Let me turn the page here. This example we already explained. Now I'm going to use two additional examples, which is figure 2.8, and this is as example where I'm going to choose these the directions factors here. As you can see that the problem has a square added on the xy plane, and then a point which is we are interested in. So this is our point P. Now it totally have four sides. Let me call it a side A, side B, side C, side D. The way we do the calculation is exactly the same. Suppose we are interested in just side C here. Then we are going to choose the line element. Remember, the integral itself has these line element involved. As you remember, dl, dl prime, and d sigma prime, d tau prime. These are the line integrals. So here we choose a small segment, which we interested in. Now this small element, and this is called a dq prime. So now let's look at how we determine the direction, because this is the point which we are interested in to find electric field. So we draw a line like this. So now you can see I have a vector point this direction. Now you can see we're going to use the same method as we did over here. In other words, we're going to move this vector without rotating directly out to the origin. So you can choose this is your origin, or any origin will be, doesn't matter. You can choose any origin, but this is probably simpler for you to see that. So this is my origin over here, and this gave me the theta angle. Now the phi angle is also easy to find out. In other words, suppose this is your vector. You do the projection onto the xy plane, like this, right? So now you can see it. If this is your y-axis and this is your x-axis, you can still find out. So the angle will be over like that. Okay, I suppose this is the vector projected onto the xy plane. So you can find a phi. Once you find a phi, and the theta prime and phi prime can be figured out. So this is the one example. Now what happens if I have a situation like a circle, like this one here? I would do the exactly same. In other words, I choose a point over here and draw a line over through that. So this is the theta angle, which is give you the theta prime. The phi angle is over here. In this example, I'm going to show you the next video. I'm going to show you the real calculation, how we did figure this out. Now I can show you another example. If I have a more complex situation like these ones. So this is your homework exercise. You can see you have a capital letter R here, and you can choose a line, the surface element inside of this, small element inside of this, and then this point from here all the way to P, this is your R prime, R minus R prime. Again, this angle with respect to this line is your theta. Projection onto the xy plane is your phi prime. So now this is to show you how we choose these angles. Next video, I'm going to show you how do we deal with this part here. Okay, and so there are some differences.